Welcome to the DIY Honda Garage channel. The DTC P16F5 code indicates an issue with the starter cut relay 1 control circuit. Specifically, that the return signal is high when the starter is on. This abnormality prompts the powertrain control module, or PCM, to register the fault. The starter cut relay is crucial because it controls the flow of electrical current to the starter motor, which is essential for engine ignition. If the PCM detects an unexpected high voltage in this circuit, it assumes there's a malfunction that needs immediate troubleshooting. This kind of issue can lead to starting problems, where the engine may not turn over as expected. Therefore, understanding the components involved in this fault is essential for accurate diagnosis and resolution. The starter cut relay 1 plays a pivotal role in managing the power delivered to the starter motor. It allows current to initiate the engine start process, directly affecting the vehicle's startup behavior. Located within the relay circuit board, this component works closely with the PCM, placed in a protected area of the vehicle's electronics. The PCM is the brain of the engine management system, constantly monitoring various electrical signals to ensure engine performance. Upon detecting an unusually high voltage on the starter cut relay 1 control circuit, when the starter is activated, the PCM triggers DTC P16F5. It's crucial to inspect both the relay circuit board and the PCM for any signs of malfunction or disconnection to resolve this problem efficiently. There are several potential causes for the DTC P16F5 error code. First, a malfunction within the relay circuit can lead to high voltage readings. This can occur when the relay fails to operate correctly or gets stuck in the on position. Another possibility is a short circuit in the wiring, which can usher excessive voltage back to the PCM, leading to abnormal readings. This short could be due to damaged insulation or loose connections in the wiring harness. Finally, the PCM itself may be faulty, interpreting the incoming signals incorrectly. Once the root cause is identified through systematic troubleshooting, appropriate measures can be taken to resolve the issue. The symptoms associated with DTC P16F5 can significantly impact vehicle functionality. Predominantly, a primary concern is the engine's failure to start. If the starter cut relay 1 is unable to function correctly due to high voltage issues, the starter motor may not receive the necessary power. Additionally, there could be unexpected engine shutoff situations, as the PCM might erroneously cut off the power if it detects an abnormal signal. These triggers can make diagnosing the root cause challenging, as drivers may not readily connect the start failure with electrical faults in the relay circuit. High voltage readings from the relay can also be observed when using diagnostic tools, indicating a pressing need for further inspection. In the first step of troubleshooting DTC P16F5, the initial action involves starting the engine. This is critical as it allows for the real-time monitoring of the starter cut relay's behavior and its associated signals. Once the engine is running, the technician should check the starter cut relay's operation. During this observation, if the relay does not engage appropriately, it may signal the need for further inspection or replacement. Monitor the voltage levels around the relay circuit to capture any irregularities that may point toward high voltage issues. Ensuring that all initial checks are done can streamline the diagnostic process for any further troubleshooting steps. Next, the relay circuit board associated with the starter cut relay 1 needs a comprehensive inspection. This process includes looking for signs of physical damage, corrosion, or loose connections. If any anomalies are identified, they must be addressed. Following this, conduct a test on the starter cut relay 1 circuit itself. This includes verifying that the circuit isn't shorted to power, which would indicate an existing problem. To perform this test effectively, you may need specific tools to measure resistances and continuity within the circuit. Correcting any faults at this stage can prevent further complications down the line and assist in rectifying the DTC P16F5. The third step involves inspecting the external wiring related to the starter cut relay 1. Check for any signs of wear, fraying, or damage that could result in shorts or open circuits. It's crucial to follow wiring harnesses carefully, as damage may not be immediately visible, but could lead to high voltage conditions. Testing continuity and resistance throughout the wires will assist in identifying potential issues. Additionally, you should look for any loose or corroded connections that may impact the circuit's functionality. If any damaged components are located at this step, repair or replace them to mitigate risks associated with DTC P16F5. The final step in troubleshooting DTC P16F5 is to inspect and test the powertrain control module for functionality. If all previous checks have returned normal results, the PCM may be the root cause of the problem. Test its inputs and outputs to determine if it's accurately processing signals. The PCM should be checked for any fault codes or irregularities that indicate internal errors. If the PCM fails any of these tests, it would likely need reprogramming or replacement to reset normal operation. Understanding PCM functionality is essential, as it's the command center for the vehicle's electronic systems. After completing the necessary repairs for DTC P16F5, the final step is to verify that the error has been resolved. This typically involves clearing the DTC codes from the PCM memory to refresh the system. Following this procedure, start the vehicle again and observe for any upcoming issues or new DTCs. It's essential to pay attention to how the vehicle operates post-repair to ensure that the previous problem does not reoccur. Using diagnostic tools to monitor the starter cut circuit is also advisable during this check. If no DTCs reappear, you can conclude that the repairs were successful and that the issue has been effectively resolved. Preventive maintenance plays a crucial role in avoiding DTC P16F5 recurring issues. Establishing regular inspection intervals for the starter cut relay and associated wiring is key. This helps identify and address potential problems before they escalate into significant faults. Additionally, ensuring that all wiring remains in good condition will reduce the chances of short circuits that can lead to erroneous high voltage readings on the control circuit. Regular maintenance can also include cleaning connectors, ensuring tight connections, and checking for corrosion, which can all contribute positively to long-term vehicle reliability. These proactive measures are essential in extending the lifespan of the electrical components in your Honda Civic. In conclusion, resolving DTC P16F5 involves a systematic approach to troubleshooting the starter cut relay and its associated circuitry. Each step brings clarity to the underlying issue, whether from the relay circuit board, the external wiring, or potentially the PCM. Understanding the roles that each of these components plays in starting the vehicle is crucial for effective diagnosis and repair. Following the outlined troubleshooting steps aids automotive technicians in pinpointing the exact problem. Additionally, the importance of preventive maintenance cannot be overstated. Regular checks can mitigate risks associated with electrical failures. By embracing these methodologies, vehicle owners can maintain optimal operation and avoid complications in the future. Please like and subscribe to the channel. See you next time.